Alright, so after discussing section 8.1, which was a review for linear equations and inequalities, now we're ready for reviewing functions, section 8.2. So what is a function? Let's define that. A function f is a set of ordered pairs. When we say ordered pairs, we mean two values, the x and the y value. So a point is an ordered pair in the plane, whereby each x value, so the x value is called the abscissa. It's called the abscissa. It's also the first value. Okay, each x value is related to exactly one y value. Is related to exactly one y value. This doesn't require that the y has to be faithful. Only x has to be faithful, because x has to be related to exactly one y. Y can have one relationship, no relationship, or multiple x relationships. That's very important when we say functions. Domain of a function, it's the set of all x values, that are paired with at least with one y value, that are paired with a y value. And just like the x values have a domain, the y values have what we call a range. And the range of a function is the set of all y values, but those y values have to be paired with some x value from the domain, that are paired with at least one x in the domain, of that function. So domain is x and range is y. Remember, not just any x and any y. X has to be paired with a y value. Y has to be paired with at least one x value. Okay, x is the independent variable and y is the dependent variable. X is the independent variable and when we say y is the dependent variable. Okay, so if we look at just an example, if we look at trying to focus this, if we look at number 20, page 625, the domain and range. Domain is the x values, -3, 0, 4, and 15. The range is the y values that are paired with some x value, -8, -3, 0, and 6. If you look at 24, page 625, now in 24, let's see, let me look at the textbook. They're asking for 625. Okay, what are they asking for? They're asking for determine whether the relation defines y as a function of x. It's not a function. If you look at the chart in there, it's not a function, because if you look at the chart, the x value of 0 is paired with 10, and 0 is also paired with 10, with 12. Remember, no x value can be paired with 2 or more y values. It has to be one x with one y. Y can be paired with as many x's as it pleases, but not x. Let's look at 34, page 625. Alright, let's see what's in 34. Again, is that a function? It does look like a function because no x value is repeating with 2 or more y values. Okay. Now, so how do we identify functions if we're given ordered pairs? We just look at the x values as long as no x value is repeating. How do we identify functions given an equation? Identifying functions given their equations. You can start out by making a t-chart, and once you make a t-chart, then you check if any x is repeating. Check if any x value is repeating. If it is, then it's not a function. If it's not, then it is a function. If you look at 38, page 625, y squared equals x. If you make a t-chart, we're gonna because x equals y squared, we're gonna pick y values. Usually we pick a couple of negative, 0, and a couple of positive. So if you do -2, plug it in for y and square it, you get a 4. -1 squared is 1, 0, 1, and then 2 squared is 4. You can see the 4 is repeating with 2 different y value. 4 is an x value, so it is a non-function. If you look at 42, from that same page, 625, y equals absolute value of x. Again, since y is isolated, we're going to plug in the x values. Absolute value of -2, absolute value of -1, 0, 1, and 2. No x value is going to repeat. Usually when you have, so it is a function. Usually when y has an even power, like 2 or 4 or 6, or y in absolute value, that is not a function. Okay, now what if we're given the graph? How do we know it's the graph of a function? So identifying the graph, a function given its graph. Identifying a function given its graph. What we do for that, we use what we call the vertical line test. Because if any vertical line crosses the graph of a relation more than once, like this one, see this x has 2 y values to be paired with. So if any vertical line crosses the graph of a relation, then more than once, then that relation is not a function. So no vertical line can cross the graph of a function more than once. No vertical line can cross the graph of a function more than once. Okay. I'm grabbing my stuff that fell. Sorry. So let's look at some examples. So if you look at 54, page 625, 54, page 625. Let's see what's in 54, page 625. It says given g of x equals x cubed minus x, find g of 2. That's easy. Plug in the value. 2 cubed minus 2, 8 minus 2 is 6. So that's just, I'll just do part A. And then if you look at the next one, 64, that I want to do, again, plug in the values. H of x equals x over x squared plus 2. Find, I'm going to do h of negative 2. So plug negative 2 in there. So you get negative 2 over 4 plus 2 is 6, which can be reduced to negative 1/3. Okay, just easy plug in values. And number 68, page 625, we have h of, or f of r, f of r equals negative 2r squared plus 1, and we want to fill in the blank, input, output. So input is your r, because it's usually x, and output is your y, or f of r. So if you're inputting negative 1.7, you put it in your calculator, negative 2 times negative 1.7 squared plus 1. I did the math. That's check. Make sure you check that. If you input 0.9 squared plus 1, and I got negative 0.62. What you have to do, you just write it in as is. If you have a graphing calculator, or if you have scientific, you got to do the number you square, then times by negative 2, then plus 1. So if you have a scientific calculator, you're going to do parentheses negative 1.7, right parentheses, square, plus times negative 2, or times, times, so equal, let's erase that plus sign, equal, times negative 2, that's if you have scientific, and then plus 1. Now if you have a graphing calculator like the one I have, you just write it out as is, negative 2, left parentheses, negative 1.7, square, plus 1. Okay? And so on. So 74, if g of x equals 2x minus 7, find g of w. All you have to do, if you have a number, you plug it in for x. If you have a letter, you plug it in for x. So you plug the w in for x, you get 2w minus 7, and that's all we can do because we don't have a number to plug in. Okay. So how do we find the domain in like number 80, page 626? Domain. Remember, domain is x values where you can actually find a y value. Domain of part A, g of x equals absolute value of x minus 17. Well, to find the domain, you want to check, can I plug in a negative number and get a y value? Like if I plug in negative 1 or negative 2 or negative 3 and subtract 17 and do absolute value, it's still going to be a positive number. So I as long as I can find a y value. So no matter what I plug in, negative, positive, I still get a y value. That means it's all real numbers. Any number can be plugged in and paired with a y value. Now, it's not always going to be like this. Look at part B. F of x equals 5 over x minus 4. It looks like I can plug in 0, 1, 2, negative 2, 3, as long as I don't plug in a 4. Why 4 is not going to be good? Because 4 minus 4 is 0, and a number divided by 0 is undefined. So that's why 4 is not in the domain. Why it's not in the domain? because it cannot be paired with a y value. If you plug a 4 in for x, y is undefined. So any real number is in the domain except 4. We can write our answer like this, or we can write negative infinity to 4, not including 4 by using parentheses, union, or we can write or 4 to infinity. So this covers the whole number line except 4. Okay. Now when we say linear functions, any linear means its graph, it's a straight line. Anything that looks like this is called a linear function. Y equals mx plus b, or f of x equals mx plus b. X is the first power, m is called the slope, and b is the y-intercept. Again, this is a review from beginning algebra. So for example, if you look at page 626, number 86. It says graph each function, f of x equals 2/3 x minus 2. We can graph this in two ways. It'll probably be easier to do the slope-intercept. The slope is 2/3, and the y-intercept is -2. But -2 is a number. The y-intercept is the y value when x is 0. Y value when x equals 0. So if you put a 0 for x here, you get y equals -2. So the y-intercept is actually 0, -2. It's always going to be 0 for x, and the y value is your y-intercept. So if you want to graph it using the point and the slope and the y-intercept, you could just start at the y-intercept, which is at -2 on the y-axis, and then use the slope as rise over run. So you're going to start at 0, -2, you're going to rise 2, it's positive, so you go up 2, run 3, to the right 3, you get another point, which is at 3, 0, you connect the 2 points and extend the line in both directions to get the graph. Well, let's try 100, page 626. Number 100, page 626. It says write the equation of a linear function. So they want y equals mx plus b that passes through -2, 2, and 2, -8. These are the two given points. We need, okay, in beginning algebra we learned we could use this form, or we could use y minus y1 equals m times x minus x1. The beauty of this one, this is easier if you have the y-intercept. This is more general. x1, y1 is any point, and you have 2 points. None of them is a y-intercept. So it's easier to use this form to find the equation of the line. The only thing is we're missing the slope. And to get the slope, we do the slope formula, y2 minus y1 over x2 minus x1. We plug the values in, -8 minus 2, and then 2 minus -2, minus negative, which is going to turn out to be a positive. So that's -10 over 4, which can be reduced to -5 over 2. So now we go back here. Y minus, since I labeled this as x1, y1, I'm going to use that. It doesn't matter though, I could have used the other point. So y minus 2 equals -5/2 x minus -2. So which would be x plus 2, but this is not enough because they want this form, y equals mx plus b form. So we have some work to do. Distribute -5 over 2 times x, -5 over 2 times 2 is going to be -5. We still have to add the 2 to get y by itself, and this is the linear function that passes through the points -2, 2, and 2, -8. And this ends section 8.2.